This is a very interesting question. It states that an airplane is observed by two persons traveling at 60 km per hour in two vehicles moving in opposite direction on a straight road. To an observer in one vehicle, the plane appears to cross the road track at right angles, while to the other observer in other vehicle, the angle appears to be 45 degree. At what angle does the plane actually cross the road track, and what is the speed relative to the ground? In this case, let us first of all draw the basic information which is given in the question. It says that there are two vehicles, both are moving in opposite direction. So let us say one vehicle is moving in this direction. Let us call its velocity v1 and this point as A, and it is moving in this direction. Second vehicle is moving in this direction, okay, and let us call this as point as B, and this is the road extended up to, okay, so this is the road, and to the vehicle v1, and let's call this a velocity v2. We can say the vehicle which starts from point A with the velocity v1 observes that the plane is at 90 degree with the road. So it means it is going in this direction. Let us call this position P, and it is being observed from this point at an angle of theta. So this is the velocity or relative velocity Vp1, and let us call this as velocity Vp. And second, it is being observed by the observer which is sitting in the second vehicle at an angle of 45 degree. So this will be the angle of 45 degree, the road. So this is the basic information which is available. Okay. So what we do, we use the equation of the relative velocity. Okay, so let us say if Vp1 is the plane, if Vp1 is the relative velocity, of the plane with respect to ground. Okay, so we can say that Vp1 can be written as Vp minus V1. So from here we can find out the value of Vp. So Vp will be equal to Vp1 plus V1. So okay, the second case similarly for, okay, and this is for car 1. Okay, car 1 means which is going to start from point A. Similarly for car 2 which starts from point B. Okay, same equation or similar equation, we can write that Vp can be given as Vp2. Oh, this is Vp2. Sorry, Vp2 plus V2. So let us call this as point O. So in triangle BPO, so in triangle BPO, we can find out the tangent of 45. Tangent of 45 will be equal to Vp1 divided by V1 plus V2. Okay, and tangent of 45 is 1. So we can say that Vp1 will be equal to 60 plus 60 into 1. That will be coming as 120 kph. Okay. So from now we can find out what will be velocity of the plane Vp. Okay, this will be equal to V1 square plus Vp1 square and its square root. So we already know V1 is given as 60. So this will be equal to 60 square plus 120 square and its square root. So we can find out the relative velocity of the plane Vp. This will be coming as 134.16 km per hour. Okay. And second, it has asked for the direction. So we can find out tangent of theta. We can say that tangent of theta will be equal to Vp1 divided by Vp. Vp1 is 120 and V1. Okay, and this is 60. So we are going to get this 2. So theta will be equal to tangent inverse of 2. So we get the relative velocity of the plane with respect to ground is 134.16 km per hour, and it will be moving in the direction that is theta, that will be given as tangent inverse of 2. So this was the question. Thank you.